Looking at these two pictures, how can we best summarize the height of these two teams? Well, you can say, I can use the average or the mean of the height for both teams. So you can calculate the mean for the first team. That will come up to 110 cm. And if you calculate the mean for the second team, you will also find this to be 110 cm. Obviously, in this particular case, the mean is not the best statistics to represent the height for these two teams. It is obvious to the eye that the height for these two teams are actually different. Well, where is the difference? Well, the difference is in the spread of the data. So then the question is, how can we best measure the spread of the data? One measure is called deviation from the mean. Basically, what we have is the data minus x bar. That x bar here represents the mean. So for the first data, 140 minus 110, I get 30. And then 120 minus 110, I get 10. And then 100 minus 110, that is minus 10. And then I use the same process to fill up the column. So here, I fill up the column. So here's the answer. And if I sum up all this deviation, I find that this deviation happens to be 0. The sum of the deviation doesn't have to be 0, but as in this case, by accident, the sum can actually be 0. So obviously there is deviation, but the sum of the deviation is not always a good statistics. So how do we solve the problem? Well, one way to solve the problem is by squaring the deviation. So 30 is square, that gives you 900. 10 square gives you 100. Negative 10 gives you 100. Basically, this process get rid of the sign. And the sum of this deviation square is 2000. And what we usually do is that we take this sum of 2000 and we divide it by the total observation. This particular value is called the variance and usually represented using s squared. In this case, the variance turns out to be 333 and 1/3. And also there's another concept called standard deviation, which is basically the square root of variance. So if you take the square root of 333 and 1/3, you get roughly, standard deviation is roughly 18.3 to 3 significant figures. So standard deviation is often used as a measure of spread. And the symbol for standard deviation is just simply S. I want to pause the video and calculate the variance and standard deviation of the height in this particular team. Here's a hint for you. You may want to start with a table similar to this one. And I have already calculated the total for the first column for you. That is 6,600. And the number of observation here is 6 with a mean of 110. You may want to complete the other two columns before pressing play. Here's the solution. Do you get this right? The variance here is 100 and the standard deviation here is 10. The summary. We obtain that the variance for the second team is 100 compared to 333.3 for the first team, and the standard deviation for the second team is only 10 compared to 18.3 for the first team. These two values are consistent with the smaller spread of the height in the second team compared to the first. Here there are two exercises which I would like to encourage you to complete. Thank you very much for watching. Bye-bye.